This is video 1 for the mechanical power transmission unit. So we have 4 learning goals for this unit. I want you to be able to discuss the different types of gears. I want you to be able to describe the relationship between pitch, tooth count, and the diameter of a gear. I want you to be able to calculate the mechanical advantage of a gear system and describe the purpose of an idler gear. So for power transmission, this is how we transfer energy from where it's stored to where it does work. So basically from the battery to the wheels. And the energy itself must go through the motor, gears, axles to the wheels. So there's lots of places where energy could be lost. So for us, we use some sort of, what I want to talk about is like the drive shafts and the gears and the axles and things like that. And out in industry, there are many different types of drive shafts that you can be used. A very common one is a circular drive shaft with a special keyway, and then you'll find a little notch in a gear, so that that keyway will line up with that notch, and that helps spin it. In your car, if you were to tear apart the wheel in your car, you'd find a spline shaft at the end of the axle, and then that meshes together with specially designed gears as well. And maybe some lighter applications, maybe a hex shaft. For us, in our system, we're going to use square drive shafts. And it just makes things a little bit easier. So square drive shafts, and then all the gears will have square ports for them. However, the pieces of structure we use also have square holes. So because we're using square drive shafts and square holes, we have to use something called a bearing. And that's something that allows the drive shaft to spin around inside of it. So the bearing's perfectly circular, and you notice that on the drive shaft, just the edges touch the bearing. And since there's so little surface area touching that area, it's actually quite low friction. So these square shafts are actually very efficient at delivering power. Now we have many different types of gears that we can use. The first type is called a spur gear. Now the spur gear is the most common. And basically the purpose of a spur gear is to transfer motion between two parallel drive shafts. So when we take a look at these gears here, we would have a drive shaft here, and we'd have a drive shaft here. So that allows us to transfer the motion between two parallel drive shafts. The next type is a bevel. And kind of like spur gears, they're pretty common, but the purpose of a bevel gear is to transfer motion between two perpendicular drive shafts. So we would see we'd have one drive shaft coming through here and another one here. Now, we'd have to be careful that the drive shafts don't hit each other in the center. So oftentimes what you'll see is a little tiny set screw in the collar of one of these bevel gears. Ours don't have that, but out in industry you would normally see a little tiny set screw that would keep that drive shaft from sliding in and out. and interfering with the other drive shaft. But this is something as you're designing you have to be careful. You don't want these drive shafts to hit each other. The next type is similar to a bevel gear, and it's a crown gear. So it's a type of bevel gear, and just like the bevel gear, it transfers the motion between two perpendicular drive shafts. So we'd have one through here, one through here. Again, we have to be careful that in that region that the drive shafts don't actually hit each other. The next type is a worm gear. And, just like with the bevel and the crown, it's between two perpendicular drive shafts. Unlike the crown and bevel, you don't have to worry about those drive shafts ever touching. So they're perpendicular, but you don't have to worry about them hitting each other. Something else that's special with this is that these have a very, very high mechanical advantage. Because of this, you can only put the motor on the worm gear itself. That's the only place you can put the motor. If you were to try to put the motor on this spur-like gear, this system, it will not turn that worm gear. There's just too much friction. So because of that, this allows it to work as a brake. This system will only take input from that worm gear. And actually, generally we call this the worm gear. We call this the worm wheel. So you cannot put a motor on the worm wheel, but you can put a motor on the worm gear. The next type is called helical gears. They look similar to spur gears, but you'd notice that their tread pattern, or the way that the teeth are designed, it makes them kind of in this cross pattern. Helical gears are nice because they can transfer between either parallel or perpendicular. So they're very similar to spur. Typically we find helical gears in transmissions of cars and things that have a very high speed. They're very good for very, very high speed applications. The next type is the planetary gears. And what's nice about these is that any gear in this system can act as an input. The way that these are worked is we have an outer ring, and then inside we have planetary gears going around a middle sun gear. That's why they're called planetary. And there's a wide range of applications that can be used for these. Usually the planet gears are attached to a plate of some kind. Finally, we have the rack and pinion gear. And what this does is it converts rotational motion into linear motion. So if you have something that needs to slide out, maybe a steering system of some kind, uh, you may have heard the term rack and pinion steering for a car. This is what it uses, some sort of rack gear with a pinion gear as well. Well, that will conclude video 1.